All right, welcome back. I wanted to illustrate why you have to be a little bit careful with how you set the constants. Okay, so this is an example. Let's take dy dx equals 1 over 2y, okay, with y of 0 equals 2. All right, so let's go ahead and solve this. So 2y dy equals dx, okay. Integrating both sides, we get y squared equals x plus c. Okay, now there's two options that we can have. Okay, so the option that is the right option is that we're going to take y equals plus the square root of x plus c. Okay, and y of 0 equals 2. Okay, that implies that c equals 4. Okay, so we get y of x here equals the square root of x plus 4. Okay, so now if we do this, let's actually just take the derivative here. Well, that's going to be 1 over 2 square roots of x plus 4. And that is indeed, okay, that is indeed equal to 1 over 2y, right? Let me move this over here a little bit. So we'll call this the right path. Checks out, solves the differential equation. Okay, now there is the wrong path. Okay, the wrong path says, well, the c doesn't matter. C doesn't matter, right? It doesn't come in, it doesn't, but we're saying in the wrong path, we're going to say this taking the square root does not change the character of the c. It does, that's why this is the right path, but we're going to see what happens if we assume it doesn't. So this is a wrong path. And then we're going to say y equals the square root of x plus c. Okay. Y of 0 equals 2 implies c equals 2. So y of x equals square root of x plus 2. Now let's take the derivative of this y. 1 over 2 square roots of x. Is that equal to 1 over 2 square root of x plus 2? That is not. Okay, so you have to make sure you keep in mind, does my operation change the character of the constant? Okay, the way the constant is working. Okay, so this is just an example of why you have to take the square root of the c. Okay, effectively, the only thing, or the things that don't change it, are like multiplying by constant, dividing by constants, adding or subtracting constants. But once you start taking square roots or exponentials or logarithms of constants, then you have to carry around the constant inside those operations. Okay? All right, let's do some more examples. This is a full differential equation. This is a differential equation, number 16 in your text. And it is dy over y plus y e to the cosine x sine x dx equals 0. Okay, so the first thing we're going to have to do is we're going to have to make a little bit of some algebraic manipulations. Again, these are the magical manipulations, but they're okay because we're in a differential equations class. So negative y e to the cosine x sine x dx. Then we're going to go ahead and divide by this y. So we get, oh, let me change the color here. Okay. So we're going to get dy over y squared. Let me put the negative sign here. Equals e to the cosine x sine x dx. We can integrate here, no problem. Okay, once we do the integral here, we get y to the 2, add 1 y to the negative 1. The negative sign cancel equals, now here on this side, we're going to have a u equaling cosine of x. du is negative sine x dx. This is going to be simply negative e to the cosine x plus a constant c. Okay. Now, let me write it like this. Now, when I do the reciprocal, that is going to change the character of the constant. So that means we're going to have to keep the constant around. We're not going to be able to just suck it in. So y is going to be 1 over c minus e to the cosine of x. Okay? If you have any questions, please make sure you write them down, and during the live session, we'll go ahead and we can discuss those. All right? All right, let me go to another page. So I'll go to another page in another video. See you soon.